So this video is going to go through the 2025 section B 3 question, which is on perspective projection. So it tells us the image on the right shows a laundry kiosk, and figure B3 below shows the plan and elevation of a similar kiosk, and a pictorial view of the kiosk is also shown just here. Surface B is a solar panel as an inclined of 15 degrees, you can see that area there, and it's 15 degrees to the horizontal plane. Part A, then draw the given plan. This is the view we have here. Part B, make a perspective drawing of the kiosk given the following. So the spectator point is 130 mil from the point A, so point A is our corner here. The picture plane is touching point A, so the picture plane is going to be in contact here with it. And then the horizon line is 105 mil above the ground line. Use an auxiliary vanishing point to determine the surface B. So we can't basically use, say, our height or work out our height and then use that measurement. We have to actually use our 15-degree slope. And then part C, then on your perspective drawing, determine and indicate the height of point C above the horizontal plane. So I want you to actually work out then the height of it. So to start off, I'm going to draw the plan first. So I'm going to keep it up to the top left of the page, and it's a scale of 1:1 as well, so I don't change any measurements. So I'm just using basically the measurements I'm given in the actual question here. Corner A there, and then where this line cuts across the diagonal, that's what gives me how far back surface B is going. And then when I take this across, it gives me corner C there, and then back down there, and then the outline is heavy. There's going to be a hidden detail line going across for the overhang of the roof just here. Excuse me. And that is surface B there. So we're told it's inclined at 60 degrees. So from corner A, we can go off at 60 degrees, and we're told that the spectator is 130 mil away. It's 130 mil, and there's where the spectator will be standing. So, to get our perspective set up, we need to get our picture plane next. So, from the spectator, to find our picture plane, we look off to the right and we look off to the left to the furthest points we can see on the object we're drawing, which happens to be that corner there and that corner there. And from there then we bisect that angle, and our picture plane is going to be inclined perpendicular to that. So that's our angle. What I want to do then is draw a line perpendicular to that. So you can use your adjustable if you want. I'm just going to use sliding set squares. And what we want to do then, arc off P there for our picture plane. And we'll have to extend this out actually a bit more, because what we're going to do then is find our vanishing points, which are found by going parallel from our spectator to our extreme edges here and here. So basically we're taking a horizontal line across here, that give me VP1 on the picture plane. And then take it up here parallel to this side to give me VP2 on the picture plane here. And what I'm going to do now is I'm going to pause the video, because what I want to do is turn this view around so that I have my picture plane parallel with my T-square, so it makes it easier. But if you want to keep using your adjustable, you can. For me, I'm going to switch it around, so just give me 1 sec there. So that should be set up there now, and I've had to just zoom out a good bit because you need to have space underneath to actually fit the answer. So I'll try and keep it as close as I can to the space here. So the next thing is I have it all set up now. I have my picture plane parallel with my T-square, and what I'm going to do is from the spectator I'm going to put my vanishing points just from there. Try to keep this as close as I can together. If it goes a bit to the spectator, it'll be grand, but just so it's easy for you to see. So in the question it tells us the horizon line is 105 mil above the ground line. So I'm going to go, yeah, about 110 will be plenty there. So 0 there and then 105. Keep myself 5 mil away from the spectator, and that should be plenty of space there. I'll try to avoid the board moving as much. So this is my horizon line, and what I need to do now is take my vanishing point down. So I have VP1, that's where it is there, and I have VP2, that is it there. So now it's about building up the perspective view, which you can kind of see here. It's given to you what would create is something basically like that there. So first corner I'm going to take down is corner A. It's touching the picture plane, so everything from there I can take as a true height, and that's going to go back to VP2 there to represent that surface. And then for this surface going along the front, I join that to VP1. So everything's going back this way is going to go to VP1, everything going back this way is going to go to VP2. So to get my extreme widths, I already joined that corner back to my spectator, so where it hits the picture plane is what gives me my new width. And now I can see how wide it is in total here. It's going back to that point there, and I'm going to take my height from there. And the same from this corner when I joined it back originally to find my picture plane. Where it hits it, that now gives me how far back that object is going there. Now with this one there is a bit of an overhang, so the front of the actual kiosk is going to be back here somewhere. And we can see with our dashed line there, that is where it goes back to. So I join it back to my spectator, and where it hits the picture plane I take it down, and I can see this line vanishes off to the left, or vanishes off to the left here. This corner vanishes off to the right, so I can take the corner there on the ground back here, and what I now have is this line here is going to be the front of the kiosk then, and that is where it'll go straight up then from there. So that's how I get my outline of it. So for heights, the height of the front of the kiosk, we're told it is a total of 85 up to the top of the roof. And my first height I'm going to take is minus 10 from there, which is 75, and that is for the front edge of the roof. And because the front edge of the roof is touching the picture plane, I can take that as a true height from here. So I can take my 75 mil there, and I can join that back here. And this is going to be the front opening of the kiosk. It's like a clear glass panel there. I can join that back there then. And that slope on the roof is going to go back to hit the front wall of it there. And that can go across around there. And that will go across there as well, and it'll go all the way across to where it hits the front edge here. So I'm drawing currently it's kind of like a perspex screen at the front and the sides. and that joins back, like that there. That front edge slopes back here. This front edge will also slope back, and it'll slope back to where that edge goes across to meet it, which is here. Now, let me see. So next we need, oh, I should have drawn that in heavy. I'm going to rub that out in a bit. You won't be able to see that because it's going to be covered. So we'll ignore that for now, because that is going to be, what I've actually drawn in is that edge going back there, but you can't actually see it. So I'll rub that out a bit. And what I want to do then is, I want to take the section that goes up on the roof then, which is this part, where it's going up another 10 mil. So you can see where I got it from here. My total height was 85. That 10 mil line going down was for that height there. So once again, corner A is touching the picture plane, so I can add that 10 mil on there to give me my 85. I can slope that back there and slope it back there if I want to as well. The key thing I want there is to get it going up to that height, going across to there, and then that will slope back to the back corner of the kiosk, which is to there. That can then be joined down there, and I won't draw it in heavy yet, I'll draw it in light because the sloping surface will block it, but that's where it goes back there, and that's where it will go back there to meet it on the top surface. So what I'm going to do is I'm going to now look at drawing the squares in front. So these squares here. So what I need to do is I'm going to mark off on my plan the widths of them, because I don't have them in my elevation. So I'll be able to mark them on that front surface there where the widths of them are, and I'll be able to take them down into my respective view. And because none of them are touching off of the picture plane, I'm going to extend them down to get their heights. So the widths given to me are 10, then it's 35. So that's the width of the first one there. It's then 10, which is to there, and 30, 10, and then it's 20 and 20. So what I'll do is I'll use a marker to show where they are. So I'll use this red one here just to mark off where the actual windows are, or the screens. So there's where one is there, next one is there, and the last one is going to be positioned there. So in our plan view we wouldn't actually see them because they're sitting on a flat surface, but that's where they will be in my plan. So to get the first one, we'll take this one here on the right hand side. First thing we're going to do is join them back to the spectator, and that'll give us our widths, and we take them down. So they're on that surface there. Now we need to work out our height. And to get our height, we want to find a point on the picture plane. So that line there, if we extend it out, will hit the picture plane, say there. We can take that down to the ground, and we can take our true height from here then and join it back. So the height we have is 15 and then 20. So I'm going to go up 15 first, and then I'm going to go up 20, and this is for the right hand side. And that is going to join back to our vanishing point here, because the slope is going off this way to vanishing point 1, goes back there, and goes back there. And now I have the position of where that window is here. So I can't just take the height straight from the ground over here up. I have to extend it out because you cannot take true heights unless they're taken from the picture plane. The only point we have is A, hence why I extended that line. Next height then, so the next one then is on the same height, so I'll just show you there. They share the same height, so I'm going to keep the 15 there, but I'm going to go up another 10 for the height of the second rectangle or square. And it's now going to be these two heights. So I join these back to my spectator. So it'll be that there, and it'll be this one here. And I take them down. And this will give me my second one there. And the last one I'm going to do the same thing again. Join it back to my spectator, that corner there, that corner there, take them down, and the height, first height is going to be up 25 from the ground, join that back there, and then it goes up another 35 from the 25. Like that there. Now the next thing then is to get the slope of the roof. So we're told it's at 15 degrees and the slope is going off this way. So what we're going to do is from the spectator, we're looking out to our vanishing point. We're going to look up at 15 degrees from there and take our vertical height then. Imagine that's your ground, and then we're going 90 degrees then up. So we need our protractor for this one. So we're looking at 15 degrees. Just make sure of that. Yeah, it's at 15 degrees. And then join that back to the spectator and go perpendicular to what I would say is kind of like the ground, because the spectator stand there looking off at the horizon there. And the height is going to be this height here. And we mark that with a colour. Call it AVP for auxiliary vanishing point. And we'll take that distance, and that is going to be marked above here. There's AVP for auxiliary vanishing point. That's how we find the slope. If you were to work out the actual heights by drawing the elevation or the end view, you wouldn't get any marks for applying the height there. You have to use a perspective auxiliary vanishing point to get it. Now for the front edge of it, there's where the slope occurs. It comes all the way out to the front of the kiosk here. So I join that down to my spectator, hits it at that point there, and that hits the front of the roof at that point. On the other side, joins back, goes down, hits off it here. That's where I can join my auxiliary vanishing point off to there and there. Now that goes back as far as this corner here. So to actually find that perspective, what I can do is I can extend that out and put it on that line. And if I join that back to my spectator, and where it hits it, cuts across there, I can join that back, because that's going back along that vanishing point, and then along that line is going to be that corner there. And if I join that back to the spectator, I can take it down, and that gives you that corner, which gives me then the height for the slope goes off it. And that then joins back to VP1 there. I now have a slope surface on the kiosk, and I can then draw the back corner there, extend this corner here, which I originally didn't have. And that is part B then complete, I believe. I have my front part here, that part there, I have my 3 panels there, I have my slope going off at 15 degrees, and then the last part then, on your perspective drawing, determine and indicate the height of the corner C. So what I need to do is work out the actual height of it. So to do that, I can extend corner C to hit the picture plane. I can take it down to the ground line. So remember, you can only take true height somewhere it touches the picture plane. So I'm moving corner C from here along that line, touch the picture plane. Take it down, I can measure its height from there. Corner C is on that line there, which is parallel to my vanishing point here. There is corner C in my perspective. If I extend that all the way across there, it'll give me my height where it hits my line to extend it out to get that in my perspective. If I measure that there, then that is 97 mil. So 97 mil is the height that point C is off the ground. So there we go, that is part A. Part B is my perspective, and then part C is working out the height of corner C. So hopefully that video helps anyone who may have been stuck on completing that question there.